Chapter 9, question 23 goes straight from the raw data. Research examining the effects of preschool childcare has found that children who spend time in a daycare, especially a high-quality daycare, perform better on math and language tests than children who stay home with their mothers. In a typical study, a researcher obtains a sample of n equals 10 children who attended daycare before starting school. The children are given a standardized math test for which the population mean is mu equals 50. The scores for the sample are as follows: 53, 57, 61, 49, 52, 56, 58, 62, 51, and 56. Step 1. What are our hypotheses? This question continues, is the sample sufficient to conclude that the children with a history of preschool daycare are significantly different from the general population? Use a two-tailed test with an alpha of 0.01. So our null is that the sample comes from a population with an average of 50. Our alternate is that it's not equal to 50. Step 2, we need to find our critical values. So for this, we need to have our degrees of freedom. N minus 1, we have 10 scores minus 1. Our degrees of freedom are 9. If we go to table B2 in the textbook and we look at degrees of freedom of 9, where the amount in both tails combined is 0.01, so our alpha is 0.01, two-tail. What we find is that our critical, T critical, is equal to plus or minus 3.250. So it's plus or minus because it's a two-tailed test. Step 3, we need to calculate the test statistic. So that's going to go up here. In order to calculate the t, we need the estimated standard error. In order to calculate the estimated standard error, we need to calculate the variance. In order to calculate the variance, we need to calculate the sum of squares. And so we're going all the way back to chapter 4, where we learned how to calculate the standard deviation and the variance. I am going to use the computational formula versus the definitional formula. So for this, the sum of squares is equal to the sum of x squared, subtract the sum of x squared divided by n. So what I need to do is I need to take each of these x scores and I need to square them. So I've already done this, so I will just write this out so that we see it. So what I've done is taken each of these scores and squared them. I need the sum of x. The sum of x is adding all of these scores together, and that is equal to 555. I need the sum of x's squared, so that is each x value squared and then added up. That is 30,965. I'm going to plug these values in here. So 30,965, subtract 555 squared divided by 10. 30,965 subtract 30,802.5. So 162.5. From there, I'm going to calculate my variance. So I'm going to take that sum of squares and divide by n minus 1 because I have a sample. That's 18.06. I'm going to calculate my estimated standard error now, where I take s squared divided by n, and then I take the square root of it all. 18.06 divided by 10, square rooted, that's 1.34. And now I can calculate my test statistic, my t-test. So that is t equals, I need one more step. I need to find the mean. So if I need the mean, m equals the sum of x divided by n, 555 divided by 10, 55.5. So take 55.5, I subtract that population value, which was 50. See the benefit of writing this out as we read the question? I didn't have to go back and read the full word problem to get that value. I'd already pulled it out. Divided by 1.34. That's equal to 4.10. So that's step 3. In step 4, what I'm going to do, it's always best to draw this out. I'm going to put my critical values from step 2. So that was plus 3.250 minus 3.250. Anything that falls in here is going to be failed to reject. Anything that falls out here or over here is going to be reject the null. Failed to reject the null. Out here, reject the null. My calculated value was 4.10. So it falls in this critical region. So my decision is, decision, reject the null and accept the alternate. Evidence, it falls in the critical region. So for evidence, you can either use this diagram or you can say, right, 1.40 is greater than 3.250. So you reject the null and accept the alternate. And the interpretation is that there is a significant effect.